The AI arms race is reaching staggering heights. Microsoft is reportedly planning a massive AI supercomputer, codenamed Stargate. Reports suggest the scale of this project could potentially reach costs as high as $100 billion. Elon Musk is constructing a massive GPU farm estimated at $4 billion. And OpenAI's Sam Altman, he's circling the globe, seeking to raise trillions in the long term to reshape the entire chip manufacturing industry. Meanwhile, NVIDIA, the company powering this revolution, has become one of the world's most valuable companies. Their latest H100 chips, each one costs $40,000, and they can't make them fast enough. Tech giants are scrambling to secure their share of these chips, with some paying billions just to reserve their spot in line. This is what the giants of tech believe it takes to win the AI race: bigger data centers, more powerful chips, unprecedented amounts of capital. But in 2023, while tech titans were planning these digital fortresses, a small team in China was about to challenge everything we thought we knew about building AI. They didn't have access to the most advanced chips. They couldn't spend billions on infrastructure. What they had was something more valuable, a revolutionary idea. They were about to demonstrate that the future of artificial intelligence wouldn't be built on endless racks of expensive hardware or trillion-dollar fundraising rounds. It would be built on something far more powerful: intelligence itself. This is the story of DeepSeek, the company that achieved what the giants couldn't. And they did it for just $5.6 million, less than what big tech spends on their AI projects in a single day. In May 2023, while tech giants were racing to build ever larger AI models, a different approach was taking shape in Hangzhou, China. Liang Wenfeng, a successful entrepreneur who had already made his mark in quantitative finance, saw an opportunity that others had missed. Unlike most AI startups dependent on venture capital, DeepSeek had a unique advantage: financial independence through Highflyer, Liang's successful hedge fund. But they also faced a significant challenge: restricted access to the most advanced AI chips due to export controls. This constraint would prove to be a blessing in disguise. Instead of trying to match the computing power of Western tech giants, DeepSeek was forced to innovate in a different direction, making AI more efficient. DeepSeek's breakthrough came through three key innovations. First, their mixture of experts (MOE) architecture fundamentally changed how AI models process information. In traditional AI models, every piece of information activates the entire network. Imagine asking every expert in a company to weigh in on every decision, no matter how small. DeepSeek's approach is different. Their model has 671 billion parameters total, but intelligently activates only 37 billion for any given task. The second innovation was their reinforcement learning system. Most AI models are trained on what we call supervised learning. Imagine a massive data set where each input is manually paired with its correct output. For instance, a human might label millions of examples like: question, what's the capital of France? Answer, Paris. Or for coding tasks, input, write a function that adds two numbers. Output, function add A, B, return A plus B. This manual labeling is expensive and time-consuming. DeepSeek took a different approach. Instead of relying on human-labeled pairs, their AI learns through a reward system that automatically evaluates its own outputs. For math problems, it can check if its answer is correct using a calculator. For coding tasks, it can run the code and see if it works. For logical reasoning, it can verify if its chain of thought leads to valid conclusion. This is similar to how DeepMind's AlphaZero mastered chess, not by studying millions of human-labeled chess moves, but by playing against itself and learning from whether its moves led to victory or defeat. This automated feedback loop allows the model to learn more efficiently and discover novel solutions that might not exist in human-labeled datasets. The third breakthrough was their multi-token prediction (MTP) system. Think about how humans read. When you see the beginning of a common phrase like "once upon a," your brain doesn't process just the next word, but likely jumps ahead to predict time. Or when someone starts saying peanut butter and you immediately think jelly. Traditional AI models work more like a careful reader who looks at one word at a time. But DeepSeek's MTP system is more like an experienced reader who can anticipate multiple words at once. On the left, we see a traditional model processing the quick brown, one word at a time. On the right, DeepSeek's model predicts multiple upcoming words simultaneously. Fox jumps over. This parallel prediction dramatically speeds up processing. Imagine reading a book one word at a time versus absorbing whole phrases at once. For tasks like translation or content generation, this means DeepSeek's models can work much faster while using less computational power. The impact of these innovations was staggering. While GPT-4 reportedly cost over $100 million to train, DeepSeek achieved similar capabilities for just $5.6 million. They did this using only 2,000 NVIDIA H800 GPUs over 55 days. And to put this in perspective, let's look at what the tech giants are using. Microsoft and OpenAI reportedly use over 30,000 NVIDIA A100 GPUs just for running, not training GPT-4. Google's latest models are rumored to use upwards of 25,000 TPU v4 chips. And Meta's setup for Llama 2 training involved around 6,000 H100 GPUs. When training models like GPT-4, companies often run their systems for months, not just 55 days. DeepSeek R1, 2000 H800 GPUs. OpenAI Microsoft, 30,000 plus A100 GPUs. Google, 25,000 plus TPU-v4 chips. Meta, 6,000 plus H100 GPUs. This is like comparing a small, efficient electric car that can match the speed of a massive gas-guzzling supercar. DeepSeek achieved similar capabilities with roughly 1/15 of the computing power that major companies typically use. But perhaps more importantly, they proved that restricted access to cutting-edge hardware wasn't a death sentence for AI innovation. Instead, it forced them to find more efficient ways to train and run their models. Building on their success, DeepSeek introduced Janus Pro, a groundbreaking multimodal AI model that can understand and generate both text and images. What makes Janus Pro remarkable is that it achieves this in much smaller 1B and 7B parameter versions. To understand why this is extraordinary, imagine two kitchens trying to prepare the same gourmet meal. The first kitchen is massive, with hundreds of specialized chefs, each handling one specific task. One just for chopping vegetables, another just for sauces, another just for plating. That's how traditional AI models work, with billions of specialized parameters, each handling tiny specific tasks. But Janus Pro is like a small, expertly organized kitchen, with just a few highly skilled chefs who can handle multiple tasks efficiently. While other multimodal AI models might use 175 billion parameters, imagine a kitchen staff the size of a small city. Janus Pro creates the same high-quality output with just 7 billion parameters, more like a well-organized restaurant kitchen. It's not about having more resources. It's about using them more intelligently. This efficiency isn't just about bragging rights. It means Janus Pro can run on smaller computers, uses less energy, and is more accessible to developers and researchers who don't have access to massive computing resources. The model uses advanced techniques like float 8-bit numbers for computation, reducing memory usage while maintaining accuracy. Think of it as using shorthand. That's just as precise as long-form writing, but requires less space. DeepSeek's roadmap for the future is equally ambitious. They're developing several groundbreaking technologies that could fundamentally change how AI systems operate. First, there's dynamic neural pruning. Imagine your brain during sleep, automatically strengthening important connections while weakening unused ones. Traditional AI models are like libraries that keep every book ever added, even if nobody reads them. DeepSeek's approach is more like a living library that continuously optimizes itself, removing redundant connections, strengthening useful ones, and reducing computational needs by up to 40%. This isn't just about efficiency. It's about creating AI that can stay lean and focused while continuing to learn. Then there's their Biointerface AI project. Current AI models are like buildings. Once constructed, their architecture is fixed. But DeepSeek is developing neural networks that behave more like living organisms. Imagine an AI that starts with understanding basic math, but as it interacts with an engineering student, it gradually develops specialized circuits for handling complex calculations, just like how our brains form new neural pathways when we learn new skills. Early tests show these adaptive models can achieve specialized expertise while using 30% less computing power than traditional approaches. Perhaps most intriguingly, they're developing self-healing models. Current AI systems are vulnerable to data corruption, like a computer crashing and losing work. But DeepSeek's approach is inspired by how human brains can reconstruct memories even when some details are forgotten. Their models can detect corrupted or missing information and regenerate it based on context, much like how you can understand a sentence even if some letters are missing. The practical applications are vast. Financial systems that can recover from data glitches without stopping trading. Medical AI that can maintain accuracy even with incomplete patient records. Autonomous vehicles that can operate safely even if some sensors fail. Cloud computing systems that can repair themselves without human intervention. This move toward more biological approaches represents a fundamental shift in AI development. While other companies focus on making models bigger, DeepSeek is making them more adaptable, more resilient, and more efficient, qualities that mirror the remarkable efficiency of biological intelligence. Looking further ahead, DeepSeek is exploring the intersection of quantum computing and AI. Their 2025 Quantum AI Hybrid project aims to develop photonic chips that could train models 1,000 times faster than current methods. They're also working on Project Lazarus, an ambitious initiative using quantum AI to reverse engineer extinct plants for medical applications. Early trials have already shown promise in recreating compounds lost to history. DeepSeek's innovations are already finding real-world applications. Their efficient models are being used in everything from climate modeling to medical research. Because their models can run on less powerful hardware, they're enabling AI applications in regions and situations where traditional models would be impractical. Their open source philosophy has also sparked a wave of innovation, with developers worldwide building upon and improving their efficient architectures. DeepSeek's story is more than just about overcoming hardware limitations. It's about how constraints can drive innovation. By questioning the assumption that bigger is always better, they've opened new possibilities for AI development. As we look to the future, their approach suggests that the next breakthrough in AI might not come from having the most powerful computers, but from finding smarter ways to use the resources we have. Thank you for watching this documentary on DeepSeek, the dark horse of the AI revolution. If you found this story inspiring, please consider subscribing to the channel. It really helps us bring you more in-depth content like this. And if you want to dive even deeper into the world of AI, check out the next video from our playlist. You won't want to miss it.